Hi everyone. In this video, I will be explaining the difference between global variables and local variables and when to use them. Let's create a sample processing sketch. Here's my sketch. In the previous video, we've already talked about setup and draw, so I'm not going to worry about that. We've also seen that setup typically has size and background implemented. Draw typically erases the background and then draws the remaining animation. Now, we've seen variables are values that have a label. So when I say int x, x is the name of the variable and int is the type of the variable, denoting that it can only hold whole numbers. When I say int x, it creates a label in the memory, which is 4 bytes, because integers are 4 bytes. And whenever I use x, it refers to that memory. So when I say x equals 10, the contents of that memory become 10. And then I can display x. And in the console, you can see that I get 10. Can I say x equals 1.5? I can't, because x was declared as an integer and 1.5 is not a valid integer or whole number. If you'd like to store decimal numbers or real numbers or floating point numbers, then the data type to use is float. So here, float x is 1.5, it becomes 1.5. Can I store an integer in a float? Yes, we can, because all integers are real numbers, but all real numbers are not. All integers are real numbers, but all real numbers are not integers. So if I keep it as 15, it will be stored as 15 and displayed as 15.0 because it's a floating point number. So that's an integer and float. So we can say x, and I can combine declaration and assignment together. So I can also say float y is 1.4, and I can display x followed by 1. So you can see x is 15, no dot 0 or 0.0 because x is an integer, and y is 1.4. When you assign a value, you can also assign a complex value like 2 plus 4 times 5 minus 6 times 7 remainder 3 and so on and so forth. So it really doesn't matter how complex the value is, as long as the value is of type integer, you can keep it in an integer variable. So when I run this, it just so happens that x is 16. We've seen operations in the lecture today. So as soon as I make it 6.0, there's a problem. Because as soon as I said 6.0, that 4 times 5 minus 6.0 becomes a floating point, and 2 plus a floating point becomes a floating point, and that floating point times 7 remainder 3 becomes a floating point. So we have to make sure that the value we are copying into a variable is of the right type. Okay, so that was a little background in variables, but the main focus of this video is local variables versus global variables. Let's say I would like to draw a random vertical line every time draw executes. I'm going to change a few things. Stroke weight as 5, stroke is red. And I'd like to draw a vertical line, but not all the way from the top to the bottom. I would like to draw a line somewhere in the middle. So from height over 4 to 3 times height over 4, or height over 3 to 2 times height over 3, in the middle third. And it should be a vertical line, but it can be anywhere in the screen, but not too much to the left. For this, I'm going to determine the random x location where it will be generated. I'm going to start with 20 and go all the way to width minus 20. So the reason I'm doing that, and again, I've talked about this in the previous video, discussing draw and setup. I don't want to go to the very edges. So I'm going to leave the 20 pixels to the left and 20 pixels to the right alone. Okay, now I can draw a line X, height over 3, to the same X, 2 times height over 3. And I run this, and you can see that I get this output. If you don't erase the background every time, the lines will keep accumulating. It sort of gives you a nice output, which looks like this. Eventually, it will become a rectangle. You can also add opacity as the 4th attribute of the color. And opacity is 255 by default, which means it's full solid color. But you can also make it 0, which makes it completely transparent, so you won't see it. And that's why 0 opacity is probably never ever used. I'm going to keep the opacity somewhere in the middle. So you can see that it's semi-transparent, and you can see some output at the back. But eventually it will build up and it will become a red rectangle. Here's an example of where a local variable was useful. X was declared inside the draw function. If I display X here, it will not execute. I will get a compilation error because, as we saw, setup executes and then draw executes. So at this point of time, there is no X in the memory. It's only here on line number 11 that X comes into existence. So if I move the println X to the bottom, then my program does execute. Here we declared the variable, and declaring means float. When I say float, that's creating the variable in the memory. I created the variable, and then I use the variable, and then when draw finishes, the variable X is destroyed. So let's confirm that using debugging. Click on this little butterfly, add some breakpoints on line number 10, 11, and 12. What's a breakpoint? It's just a pit stop. So once you click that butterfly and you click on line 10, click on line 11, click on line 12, you've created pit stops. Now, when you click on the play button, it's actually going to debug, which means it's only going to run to line number 10 and then ask for permission. Let's run this. So you can see line number 10 is a triangle, which means it stopped there. If I continue, you can now see there's X in the memory. It displays that value, and the line goes to the buffer and then to the screen. But the next time, when it comes back up, let's add more breakpoints, stop, and debug the program again. This time, it's at line number 8, there is no X. Line number 9, there is no X. Line number 10, there is no X because it's waiting for line number 10 to execute. So it's waiting for our permission to execute line number 10, no X. Zoom again, and line number 11, now there is an X. So local variables are variables that are declared inside the function and live and die with the function. Now, let's change. So let's save this as local need for local variable. And then we're going to copy this program and create a new program. This time, the purpose of my program is to draw a little animation where a circle moves from the left side to the right side. That's all. If I try to create X and initialize it to, let's say, 20, and then I create an ellipse that is drawn at X, height by 2 with diameter 40. So I kept the diameter 40 and I kept X equals 20 so that half the circle, which is to the left, is just on the edge of the left wall. If I draw this, I get a circle, but I can change this to fill and no stroke and have the background as well. So let's run this now, and you get a circle. So every time X is being created, but at the same place. Then I would like to increase the value of X by 1. This is how we can increase the value of a variable. What we are saying is X becomes whatever the current value is plus 1. Remember, assignment operator has 2 steps. Step number 1 is evaluate the right-hand side value. And step number 2 is copy it into the left-hand variable. What we're going to do is every single time we are going to display the value of X. I'm going to display it before, and I'm adding a space because I want both the X's on the same line. So I will display X before increasing and after increasing. And let's run this. And every single time you will see that the value of X increases from 20 to 21. But because it's a local variable, when the draw function finishes, it's destroyed. So again, it comes back. Again, X becomes 20. Again, it increases to 21. And again, it is destroyed. And that cycle goes forever. But I want to increase it from 20 to 21 to 22, etc. What we can do is, instead of declaring X inside the function, I can declare it at the top. You don't have to declare it at the top. You can also declare it wherever you want, as long as it's outside global variable, outside any function. So if the variable is outside the function, it's accessible in every single function. So I can say in setup, X is whatever the value of X is. And then in draw, X is whatever X is. So let's get rid of this. So we have declared X at the very beginning and initialized it to 20. X increases by 1, but it doesn't live and die with each iteration of draw. Once you create a global variable, it lives for the entirety of the program. So there's only one occurrence of X for the entire program. Okay. Let's reduce the frame rate for the time being to 1, because I just want one iteration at a time, and run this. You can see that in setup X is 20, in draw also setup X is 20, but it increases to 21, 22, 23, 24, 25, and slowly my circle goes forward. Now let's reduce the frame rate and run the program with higher speed, and the circle moves forward much more smoothly. You can also increase the speed by 1.2 and make it a bit more fast. You can increase it to 1.6 and it's even faster. 2.4 would be even faster, and so on and so forth. So the change that you make affects the speed at which the animation is drawn. So there you go. That's the reason we need local and global variables. Need for global variables. All right, I hope you benefit from this video, and until next time, take care.